Welcome to math class where math makes sense. That's the goal. Welcome to math class where math's our friend. Feel the math love. We're doing multiplicities. Multiplicities. Cha-cha. Multiplicities. Cha-cha. Bounce across with me. Cha-cha. Read your multiplicities. Each factor behaves like its parent counterpart. Sketching graphs is easy when you factor from the start. Okay, behaves like its parent counterpart. What do I mean? Well, this 0 is x equals 3. It has a multiplicity of 2, and so it's going to behave like its parent counterpart. X minus 3, quantity squared, goes right 3, that positive 3, and then it bounces right there, right? And so we're going to say that we're going to say bounce, it's going to behave like a squared function. Okay, this one. This is -4, and it's cubic. It has a multiplicity of 3. And so at -4, it's going to behave like a cubic function, and it's going to cross, and in particular, it's going to do a little cubic wiggle, okay? Now this one is x equals 0, and it's also going to cross. It's got no multiplicity. It's a multiplicity of 1, we would say, but like we wouldn't consider it a multiplicity. These have a multiplicity. The 0 is happening multiple times. And so this just crosses at that x-intercept. Okay, next part of the song. Start with the ends, then each x we have found. Does it change signs or bounce right back around? Does it change signs? Is it going from negative to positive or positive to negative? Change S-I-G-N, signs. Or bounce right back around. Usually when we're doing this kind of analysis, often what we're wanting to learn is like, maybe we're trying to solve an inequality. When is this less than 0 or greater than 0? And so changing of signs is a really helpful thing. Start with the ends. This is a 1, 2, 3, 4, 5, 6. It is a 6th degree function. All of the x's are positive. It would be a positive 6th degree function. So its ends are up and up. A negative 6th degree would be down and down, right? Odd degrees go like this. Okay. So start with the ends. Sketchity, sketch, sketch, sketch. Please notice on my sketchity, sketch, sketch, sketch. I'm not going to have any y values here. I am like really just looking at behavior. I know my behavior. I have intercepts here, here, and here. I know I start with the ends, so I start up and up. Okay, then I want to go left to right or right to left. Doesn't matter, but you're going to work one way through. Then each x you have found, does it change signs? Yes, at -4, it wiggles or bounce right back around. At 0, it crosses. Somehow I have to cross. So at some point here, it's going to turn around so that I can cross. I do not know where that turning point is. Keep note of that. Okay, then at some point it's going to have to turn back around so that it can go ahead and bounce at 3. Yay! I sketched my graph, okay? I ask my students what's accurate and what's inaccurate. The end behavior is accurate. The behavior right at the intercepts is accurate, but like this local minimum, big old question mark, local maximum, big old question mark, so we'd say the local extrema are very inaccurate. I know that there is a local min that exists between -4 and 0. I don't know where it is. I don't know if it's directly between, I don't know what the y value is. I know there's a local maximum between 0 and 3. I don't know what it is. I don't know what the y value is. So that is very inaccurate. Okay. Oh, pardon the laughter outside. I've got my windows open because it's so beautiful out today. Okay. That's how we rock multiplicities. Let's do one more for fun. We'll do one with some negatives. So let's say m of x for Maeve. Math loves Sue. We'll do a -x plus 1, and we'll cube that, and then we'll do a, let's do a fun one like a 2x minus 5, and we'll square it. So altogether, this is a 5th degree function. Okay, so when I'm looking at the end behavior, it is a negative The leading term is going to be, well, the 2x squared is going to be a 4x. I'm going to get a negative, so it's going to be a negative 4 is going to be the leading coefficient. That is a negative function. And so the end behavior looks like that. That's negative 5th degree end behavior. Okay. Start with the ends, then each x you have found. Does it change signs or bounce right back around? This x value is 1. When I plug in 1, I get 0. And it does cross. It's got that multiplicity of 3. I'm going to put my 1 there. This x value is 5 halves. So 5 halves is somewhere that's really like 2.5. Okay. Here's my 5 halves. Okay, this is just a sketchy sketch. I should probably say x and y, right? And it's gonna bounce. It has a multiplicity of 2. This one had a multiplicity of 3. Multiplicities. Okay. Start with the ends. I know my ends are up and down. Okay. And down. Then each x you have found, okay, it crosses here with a little wiggle because it crosses like a cubic. Then I know it bounces here. Oh, good, because I have to come back down somehow. I know at some point it must turn around and then bounce and then be down. So the end behavior is accurate. What's inaccurate? I don't know where this local min is. I know there is a local min. There is a turning point between 1 and 5 halves, but I don't know where it is. And you know, I could get an accurate y-intercept, couldn't I? That would be an important thing to do. You should always just rock a y-intercept. If I plug in 0, I get 1 cubed. I get negative 5 squared. So that's going to be 25. Talk about not drawn to scale. Sketchity sketch. All right. So what's accurate now is the y-intercept, the end behaviors, the behaviors at the x-intercepts. That local minimum is very inaccurate. That is, my friends, is how you use multiplicities. You can also use multiplicities to work through rational functions that are factored, and we'll save that for a video for another time, okay? Subscribe, share, like, stream Multiplicities wherever you get your music. It's on the album Funky Functions. And remember, math loves me and math loves you. Bye.